Stop that! Stop that! Aha!
Oh my god!
Eat that! You like that?
No.
Whoa! God, why is everything shaking?
I think it's an earthquake.
Earthquake here?
Yeah,
We live in Malaysia. Why is there an earthquake here? Oh crap!
No.
Oh crap! There's no signal. What should we do?
Oh, what should we do?
You're asking me. I'm asking you.
No idea, Mama. Help me.
Are you experiencing a natural disaster?
Yes.
Introducing 5G, better than 4G, 3G, 2G, or any other G.
Oh wow, what is 5G?
5G is the fifth generation of cellular mobile communication. It is a significant upgrade from 4G, which is still being widely used today.
Wow. Tell us more.
Among the benefits of using a 5G network is the ability to transfer data in rates higher than 20 gigabytes per second. The current generation of network data can only transmit a maximum of 1 gigabyte per second. This allows the transmission of higher quantities of data over a wireless network. With this, a 5G connection has a very low latency rate. A 5G network can have a maximum latency of 1 millisecond. A low latency allows data to be transmitted across one point to another much faster and more frequently, ensuring that the connection is more stable than a previous generation network. Aiding the large amount of bandwidth is the introduction of advanced antenna technology, which allows a larger amount of data that can be transmitted through the adapter. An important aspect of making cities resistant to natural disasters is to focus on communication. Through communication, information can be passed around to alert citizens of said city that a natural disaster is oncoming.
So what you're saying is that communication can be used for sensors to prepare the city for the occurrence of natural disasters?
Oh yeah, like smart drainage systems that are being developed for cities in Dutch lowland to help them combat flash floods in their neighborhood.
That is right. That is correct. An emergency communications network can be set up to help citizens that are trapped in disaster-prone areas. An application or telecommunication network can be set up using the aid of 5G. There are several technical possibilities when it comes to using 5G in an efficient manner to reduce the damage done by natural disasters. Let's talk about ad hoc and 5G networks.
Oh, ad hoc and 5G networks. I know about this. So, a 5G network utilizes small cell stations which receive the wireless signal. These small cell stations can be built into local structures such as buildings, lampposts, into pavements, and so on. This surrounds the city in a metaphorical dome of data. Well, the network is supported through a series of ad hoc connections where several systems establish temporary connection from system to system without the use of Wi-Fi. The connection does not require a router, but requires an adapter so that peer-to-peer systems can work. Excuse me, sir, I need to take this chair. Right. So, here's how the peer-to-peer system works. Essentially, there are no concrete clients or servers, as each peer requests from other peers to provide network service for both. This allows for a process communicating where processes running from different hosts can be communicated, thus allowing program to run within a host. Besides that, processes can be sent and receive messages from a socket, which is located between the application layer and transport layer. Each peer has a socket.
Hence, alright. In the context of our 5G emergency communications network, the user's mobile phones and the 5G cell stations serve as peers to establish a web of control between each other. Since the connections are ad hoc, each peer only requires an adapter to be installed, which will enable the network to be viable even if there is no internet, as an ad hoc connection does not require a router like Wi-Fi does.
So, what can 5G communication do to make city more resistant to natural disaster?
What a coincidence. This just happens to be our next topic. The first application will be an emergency communications line between the citizens and relief officials. Not all parts of the city can be resistant to natural disasters, thus requiring a reliable network for emergency communications when disaster does strike. Through a suspended mobile network assisted through adapters from the small cells for 5G and various telecommunication apparatus such as mobile phones and emergency lines, allows the users to alert authorities.
So, besides that, cities can be made more smarter by incorporating 5G into public architecture. This can be made possible to circumvent any form of flooding and making buildings more resistant to earthquakes. Anyway, the key element to achieving this outcome is through sensors with built-in adapters that form an ad hoc connection with one another when the condition is met. For example, the Dutch lowlands have a network, a smart drainage system built on sensors which is supported through the city's Wi-Fi network. When the water level reaches on a certain level, the drains transform accordingly to allow more water to be transported out of the streets. A technical eye reveals a peer-to-peer connection where the response is created when the water level reaches a certain threshold, thus prompting the creation of a non-persistent HTTP connection. That technology can then be modified to incorporate a 5G network, so there is less reliance on a Wi-Fi connection. What do you want? A fight? Want to fight? Come on. Come on. Come on.
Take this outside.
So, in conclusion, a 5G network will trump all other forms of network systems. In order to ensure that the city can remain resistant to a natural disaster, is to ensure that the communication is ensure throughout the city to avoid or at the very least provide quick relief response to the city. Thank you very much for watching our video, and please feel free to comment below and have a nice day.
Pum pum param pum pum param pum 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 param pum pum param.